Okay, thanks, Harvey, and welcome everyone. Yeah, fifth and final in this webinar series. Tonight we're going to be talking about satellite data and imagery and sort of related tools around that I think would be useful in the context of forestry here in Nova Scotia. It's interesting. So I was talking to Harvey because we did a kind of a review of available data for forestry in Nova Scotia about a year ago, and then going back and over the last few days looking at the subject again for this presentation. And there's actually been some really interesting developments and a couple new tools that I think you'll find interesting. So hopefully this is a valuable evening for you. So just where we're wrapping it up, just to look back for a moment. So we started off talking about QGIS, which is, it's a GIS system. It's free and it's available to everybody for free. It's really come a long way over the last years. And if you're interested, I think, and you haven't seen that webinar, that's a good one to start with and go back and look at. Drones were a popular subject. We had two sessions on that. One was just sort of an overview and what is and isn't possible in terms of forestry. And then last week, we actually kind of looked in more depth following the workflow of gathering the data and processing it. In between there was a couple of tools that I thought were really important that more people knew about because I don't often see them used and they're quite powerful. That's Power Query and Power BI. So I'd encourage you, if you haven't watched that one, to go back and do that. But here we are this evening, and as advertised, we're going to be talking about satellite data, specifically around what is and isn't possible with regard to forestry here in Nova Scotia. So what we're going to do, we're going to cover the basics, talk about satellite data and imagery in general, and in general concepts, what's new and available and exciting. And then in the second half, there's a number of free tools that I think are really of value that I'd like to spend a little bit of time on. We'll talk about paid versions as well, but there's a few things that I think you could start using tomorrow. So anyway, we'll spend some time covering those. So that's sort of the plan for the evening, and I guess we'll jump right in. You know, so starting from the basics, what is a satellite seeing? I think we all think of it in terms of imagery, the kind that we look at, an image from above, which is the optical kind, reflecting sunlight. Number of different satellites using that. They've been around for years and years. Landsat, I think, is 50 years now. So that's probably what most of us think about. But nowadays, there's a lot more data being captured and ways of integrating and fusing those different data sources together in a lot of interesting ways. So radar, as we'll talk about, that's coming online, has come online, and I think we're going to start to see some data products coming out of that very soon. And then the other exciting one is the JEDI off the International Space Station. So that's LiDAR. That's literally LiDAR from space, lasers from space coming down. And there's lots of interesting data and applications for that, as we'll see. When we talk about satellites, there's a wide variety of both resolution and frequency, which map directly to cost. So the Landsat, the one that it's been around forever, the most common one, 30-meter resolution. I can remember when I started in forestry, that seemed exciting. It's kind of boring nowadays and doesn't seem very useful. But what is really interesting about the Landsat data is that 50-year archive. So when we're looking at long-term trends, long-term analysis, there's lots of interesting things that can be done with that data. And it's great that it's continually being gathered and used. So we have that record a digital record of the forest through time. Sentinel-2 is really the most common one. It's probably the one we'll see the most of this evening. It's the one that's most commonly used in forestry. It's free, 10-meter resolution. So it's usable. It's not great. You're not going to look at individual trees or anything like that. But when you're talking about looking at cut areas or disturbances, those types of things, it's great for that 5-day return frequency, which is fantastic. Then we get into some other options, as we mentioned, the radar 10-meter resolution. Again, we'll talk a little bit more about that. it's when you start working with that data, it's a little more difficult. It's not as obvious as an image, but I think as we'll see, there's lots of potential there and growing. And then of course LiDAR, um, only 25-meter resolution, but lots of people doing some really interesting things with AI in order to extract more data out of that. And we get into the paid versions. Of course, there's lots of those. We'll talk a little bit more about it. But Planet is a big one. That's a 3-meter resolution available daily. Pleiades with Spot. It's basically on demand, but the 30-centimeter resolution, and that's, as we'll talk about, that 30-centimeter resolution is probably the most fine resolution that you're going to be able to get. And to do that, you're going to be shelling out some money for that. And then in comparison, drone data, 3-centimeter resolution. So obviously not the same thing, not the same purpose, but both of them can really add value. Okay, couple recent events that are all in our minds, and as we're going into another fire season, I think we're thinking about these as well. But just a really great use case for satellite imagery, Hurricane Fiona, Sentinel-2 data. Basically, the next time the satellite passed over, we were able to get post damage through NDVI indices, where exactly was the damage that happened there. So mapping that way in the past obviously would be much more difficult, and having that accurate, up-to-date information was essential. Barrington Lake fire. Again, so another indices or a ratio NBR was used to map disturbance there, just literally within days of the fire being out, and then published to the national inventory. So, and of course, our province, it's a small part of our disturbance regime, growing but small. But when we look across Canada, that imagery data that's used to capture wildfire damage is absolutely essential, obviously. Um, another sort of use and a pro and sorry, you developing and very useful tool that's coming out of these is around canopy change, so disturbance mapping, but not just for fire, for harvesting. Hansen Global Forest Change, that's a 30-meter resolution going back to 2000 up until now. So 2025 data has just been released. We're going to have a look at some of that. But that's really valuable information if you're tracking forest change over time. And then nationally here in Canada, the National Terrain and Ecosystem Mapping System, I think is what it is. That's actually disturbance going back to 1984, and which is really valuable, 30-meter resolution, but still really valuable. But not only is it, there's a disturbance here, but it's actually tracked what happened. So there's different modeling techniques they use to do that, which is really, really valuable. Forest type. So this obviously, not obviously, this can be a use case for satellite imagery, as well as actually taking that data and then extracting from it using different data models. The forest cover type, species, researchers are working on it, but that's not something that's currently typically available or available at all. I think there's a lot of research work going on into that, but not currently available. But breaking it up into softwood, hardwood, mixedwood, and wetlands is a common use case for that, and available again through our national inventory system, 30-meter resolution. And then, as I mentioned, because of this Landsat data, we can actually track that back through time, how that's changed over time, or cover type has changed through time. And again, available for free. We'll show you that. We'll get to that site here when we get into the demo part. Estimating biomass and structure. This is one that's really quickly, rapidly developing. And again, this is a case of that merging different data sources. So bringing in LiDAR, radar, and RGB imagery in order to calculate and estimate these different things. So above ground biomass, again, we can't really tell species, but total biomass is a really good, is actually pretty reliable measure through satellite imagery, again, at that resolution, 30-meter resolution that we're talking about. Canopy height, this one is really exciting. There's been a lot of interesting developments that I wasn't aware of until the last little while, and taking a look at that. canopy cover, stand volume. Again, if you've got biomass, stand volume can be similarly predicted through that. And because we're working with this time series, we could actually see the change over time, which is super valuable. Okay, canopy height from space. Yes, it's true, lasers from space. So there's a couple different sort of general versions of this. Lang was is the most commonly used one and probably the one that's most trusted. So there's been lots of testing that's gone into it. It is a 10-meter resolution canopy height model from space. So essentially, they're merging the LiDAR data from the JEDI system with Sentinel-2 optical data in order to estimate. It's an estimation, but it's really good. A 10-meter canopy height. A more recent development is the Tolan work, which is actually a 1-meter global resolution of canopy height, which is just mind-boggling. So again, it's not the one data source. They're fusing it from different ones. This one is, as you'll see, there's problems with the data, but obviously it's pretty new and getting better, and just the thought that this can be done is pretty amazing. Okay. Then disturbance alerts. So this is another interesting one that's recently developed. So as of this year, you can now literally get for your woodlot or the land that you're managing an alert if disturbance happens on it. There's a couple different systems for that. The one through NASA has been around for a while. Sorry, so like 2 years, meaning a while. From 30-meter Landsat resolution data. And then there's a newer product from Global Forest Watch, which will actually email you. So you put in your property boundaries and it'll email you if there's a disturbance that happens on it. So pretty powerful stuff. I guess just a caveat. I think we all realize this, but just like drones aren't the answer to every problem, and field plots aren't the answer to every problem, satellites aren't either. They're one tool in the toolkit. Typically, it's that higher level, landscape level type of information that you're gathering, and particularly when you want to look at things over time, where satellites really come into their own. You're typically looking at 10 to 30 meter resolution data. So again, large property, landscape, those types of things, excellent data versus a drone, as we looked at last week, 1 to 5 centimeter resolution. So a very different tool. And then of course, field plots that we're talking tree level type information there. All of them very important, and all of them working together. The value is really multiplicative in that case. So just a little bit more detail on that. Yeah, sub-hectare, you're talking drones, right? And then species identification, it's possible, but we're talking landscape level type stuff and a lot of fusing data with plot data. Sub-canopy detail, you're really not going to get that type of information out of a satellite imagery, although there's, as we'll see here in a moment, there's some interesting stuff on the radar imagery that's coming out, or data coming out assigned with that. Couple reality checks. So especially here in Nova Scotia, we get a lot of cloudy and foggy days. When you're dealing with Landsat Sentinel data, that's a problem. So even though there may be a visit, the satellite may be going over every 5 days, it's not like you're going to get a good usable image every 5 days. You need to have cloud free, and that of course can be a problem, especially in some of the months that we're familiar with. Some of the tools that we'll look at later, there's lags, right? So it's not like these are updated every minute or even every day or even every week. Most of the tools that we're going to see are on an annual basis, and even then there's a delay. So 2025 data season closes, and then there's a processing time, and then it becomes available a few months, later. And the other one is, like, for example, spruce budworm. Obviously there's some risks coming there. it's, detection isn't really an option. If it shows up on a satellite, I guess it's too late kind of thing, right? To do any planning around that. So that's not measurement of that is not really an option. Okay. A little bit more on just so that's kind of where we're at. Where are the interesting developments coming around satellite imagery? One is just the frequency. So, prior to 2024, you're looking at 5 day return. Prior to, 10 years earlier than that, it was weeks. And nowadays it's starting this year and the last year, essentially, it's every 2 to 3 days that we're getting potential imagery, which really, really increases the value or the potential usefulness of the data. That's a big part of um, where the expansioning is happening. NISAR, so this is, we've been referring to this as radar satellite um, possibilities. So the advantage here is that it's able to see down into the crown a little bit better than, not a little bit better, a lot better than RGB imagery or even LiDAR can. So it opens up a lot of possibilities around stand structure type of questions. Again, this is very, very new. So um, I don't think we're seeing a lot of the data products coming out of that yet, but I think we soon will. So that's going to be very exciting to see that. The other really big development, and I think you'll see that when we look at some of these tools, is just fusing and extracting more information out of the data through AI and machine learning techniques. So fusing together RGB imagery and LiDAR to get heights, all kinds of interesting possibilities there. And especially when we start really utilizing the radar data, I think there's going to be a lot of potential there. So speed of development is really, really accelerating. And then, as I mentioned, these alerts that are now available. This is, if you're a woodlot owner or manage a bunch of woodlots, or you don't get to every area of the area of forest that you manage, having an alert like this set up could be really important. I think if we're managing the harvest, we know where we're going to be, and typically in this area, at least, we know about fires. However, there's wood theft and illegal trespass and all kinds of things that can potentially happen. So lots of potential there, I think, and that's an area where it's really developing. Okay, so mostly we've been talking about free versions of data and software. There's also lots of stuff that you can actually purchase. Um, kind of the different levels here. The entry tier, $5 to $30 per square kilometer will get you 3 meter resolution imagery. And then in the 30 to 50, the price goes up. But again, 30 to 50 centimeter resolution is probably about the best, even when you're going to be paying for it. So I think one kind of perception that I run across is that, well, if we purchased imagery, we would have something equivalent to Google Earth or Google Maps type of stuff, and it would be up to date. Well, it's not really the case. The best that you're really going to get is 30 centimeter resolution, and then when you compare that to aerial imagery that we're used to, is probably about in the 10 centimeter resolution range. So very different than that. You're not thinking about, it's not the same detail that you're going to see from an aerial image, and definitely not the same detail that you're going to see from 5 centimeter or 1 to 5 centimeter drone imagery. However, it is an order of magnitude better than what you're going to get from the free stuff, which is typically about 10 meter type resolution. So is it worth it? It depends. Depends on the exact use case. If you need detailed cut boundary, post treatment, it's great for that. If you want to pick out sort of structural detail that you could from an aerial photo, may not be so great for that. So it kind of fits somewhere in the middle there. Um, okay, so we're going to jump into the demo here shortly. I just wanted to kind of set expectations. So there's a lot of data. Satellite imagery and remote sensing is very data intensive. There's lots of things that you can do with the raw data. That's not where I wanted to go this evening. What I wanted to do is focus on some of the really readily available, easily available, free things that are, it's not necessarily satellite imagery, but data derived from satellite imagery that I think would be useful. So that's sort of what the focus is going to be on, as opposed to getting into R scripts or Python or any kind of the tools that you would use around processing some of that data. Okay, so there's four things that we're going to talk about. One is basically Sentinel data and how to access that easily. Lots of different options. This particular one that we're going to look at is the one that I kind of prefer using. We're going to look at sort of disturbance mapping, a couple tools that you can use to get data related to when a area might have been harvested. We're going to talk about and look at some of this canopy height data from space, which can be quite useful. And then Global Forest Watch, these alerts that we've been talking about, we'll take a look at that and what's involved in setting that up. Okay, so I am going to switch gears here, and we are going to switch over to the browser and start talking about some of these things. Okay, so accessing satellite imagery, the free versions of it and paid, there's lots and lots of tools available to do that. This is just one of them. I'm sure if you Google download satellite data, you'll come up with many, many more. This is a pretty typical example of sort of what the experience is finding and gathering that data. So the first thing you want to, so logging, there's a free login. It gives you a little bit better tools and better access. If you do that, it's worth doing. But essentially what you want to do is you're going to come over here, you're going to zoom to an area of interest. So I'm going to actually, in this case, so I'm here and I know a neighbor had a harvest done, and he is actually interested in knowing what the boundaries are. He's an older gentleman and hasn't been able to get up and look at it. So we're going to take a look at that. That actually just happened this winter. So we should find it in the imagery. Oops, sorry. So we're going to go in here. We want to find Sentinel-2 data. Often there's a filter around cloud cover. So we want stuff with, I don't know, it's okay if there's a little bit of cloud cover, but let's put it like 25% is typically around where that we want to do that. And we want L2A. And now down in here, we can go to our time range. So this happened over the winter. Let's look for something very recent. So in our calendar here, we've got 2026. So we can go until, let's start until, so until today. And let's look for something that happened in May, sorry. 05, yeah, May 1st to May 27th. We'll look in there. So now hit search. It's going to go look for imagery within this area, in that time frame that meets this cloud cover type of thing. So we've got one image that showed up. Click on visualize. We've got different options, so we can look at NDVI, a whole bunch of interesting things that we can actually look at there. We're on true color. So here we are. It's loaded it in. This is just a visualization of the data in the browser that we're at. And if I zoom in here, I can actually see this is the property here, and this is the recent harvest that happened there. So I can tell, yeah, this is a good one that I want. We'll come back to another tool, but just for now, keeping focused on this sort of workflow that we're looking at here. If I go over here to download and I click on that and I go to analytical, so this is just going to give me an image. I want analytical. I want a TIFF, yada, 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 and go ahead and download. I'm not going to do that because it's quite big, but I've done that already. And what I can then do is that TIFF that I've downloaded, I can then drag into QGIS or ArcGIS, whatever I want. And I now have that there, obviously, as an image. And I can see this harvest that happened on that boundary on that property, sorry. And this is a very recent image for that particular area. The other interesting thing that I can do in this browser is actually this add to compare. So I can look at images for the same area from two different time frames and actually kind of do a screen swipe type of thing. So I'm not going to do it for this one, but if basically this add to compare bucket, and I've gone over here. So here is this area is down Gabaroos type area. So the eastern side of the Fiona damage area. So we're looking at a photograph from 2024 and one from 2022 pre Fiona. So I've added those both to compare. And then when I've got these little sliders here, I can now slide this back and forth, and hopefully this is coming through on the screen. But if I'm looking, you focus on this area here, for example, I can see the difference in forest caused by that damage. And actually, if we'd added other false color or something like that, we probably would have seen it even better. But that's just an example. So any data any imagery that's in here for the same area, add them both to compare, and then you can kind of take a look, oh, what happened in this particular area that I'm interested in. Okay, so that's the 90% of the time when people think I think about satellite imagery and getting something recent, really that's all that you need to do. Go to a browser tool like this Copernicus browser, find the area that you're interested in, find imagery that you want, hit download, copy it, drag it into QGIS or whatever it is that you want to use for that. Or you could just work in here. If you just want to quickly look at an image from a particular point in time, then that's a great tool to do that. Okay, so the next one, so now we're getting into more derived products. So this is GLAD, Global Land Analysis and Discovery. This is what they call the Hansen data. So this is that disturbance related information, which gives you on a 30-meter pixel, when going back to 2000, any disturbance happened in the forest. There's a whole bunch of different versions of this, not versions, places where you can access this data. I like this particular one because it's really easy to download the data and use it. But essentially what it is a raster layer, which is categorized by what year the disturbance happened in. So for example, if I go to my place, I know there was a harvest that happened here, and it's giving me the year. Essentially, we can look at a whole bunch of other versions of the data, but the one that you want is this forest lost year transparent. So that lets you see through the imagery. And it's pretty accurate. It's 30-meter resolution, so that's not great, but this I know is a really accurate representation of what happened there. And you can look all over. Oh, let's look at, so this is up to date as of 2025. So we should be able to see Fiona damage in here. So yes, there we go. That's it's not breaking out the years. We'll take a closer look at that. Okay, so this is the browser. You can go in and look around, find something, etc. If you want to actually download the data, there's a link right here. You come down, way down. So this is not immediately obvious. You click on the square of the world where you are, like that, and then that changes these download ones. And what you want is Hansen lost year TIFF. That one right there. So I click on that, download it. Again, then I have the data locally, and I can bring that into, let me turn that off, sorry, into QGIS or ArcGIS or whatever that I want. And I can then use that, and there's that Fiona disturbance. Interesting. So this is really useful. So in my personal use case, if I'm working on a woodlot or developing a management plan for a woodlot and I want to know when a harvest happened, I can come here and use this data in order to update treatments or apply treatments, even if there's no record of treatments happening. I can take this and overlay it with the existing forest inventory in order to get an age of the forest. So that's the Hansen data. There is also, going back to 1985, the Canadian federal government data. So if you go to the National Forest Inventory System website and you log in, and it'll take you to this browser, you can go down here to forest disturbances, forest harvesting in Canada. That brings up a map of disturbances by year that go back to 1985, which is pretty phenomenal. Downloading it's a little bit weirder. It's going to give you a big file, but essentially, if you Google open data in FIS, it's going to take you to here, and then you can go in here and find, so there's all kinds of other information in here, like forest inventory across the entire country, sorry, based on it. Forest harvest 1985 to 2022. Grab that. It's almost a gig. Download that. But when you do that, again, we can then bring that data in and see what that looks like and use it in our GIS system. Now, why we're looking at both of them. This one goes back to 1985. However, so you can see here that Fiona, it's like Fiona isn't updated. This only comes up to 2022. So there's lots of stuff missing. If you need the most recent stuff, then it's Hansen. If you're looking at more long-term data that you need, then the Canadian Forest Inventory System data is better for that. Okay. Let's keep moving. So I'm sorry, that's not what I want. Let's go back to our list of things. So go along here. Okay, this one. So this is canopy height, literally for the world. This seeing this zoomed out like this amazes me. So if we zoom in here, this is literally a canopy height model for the world at a 30-meter resolution, which is astounding. So it's pretty accurate. But it's 30-meter resolution. So if you're just looking at a woodlot, is there still wood there? Is it mature? That type of thing. Really good information for that. It's up to date. So we have a canopy height model at a higher resolution for Nova Scotia. However, it's clearly out of date. This is as of 2022, I believe. And again, this is derived lasers from space and then data fusion with other data sources in order to derive that product. So, and this can be downloaded. So if you, it's a little bit difficult to find, but if you go to this web address, and we'll include this in here, all of this entire grid for the world, if you click on any one grid, you can then download that data as a canopy height model TIFF. And again, once we do that, we can bring it in here, turn that on, and yes, we have a 30-meter resolution canopy height model for the world as of 2022. And when I poke around, it's pretty accurate. So that's 30-meter resolution stuff. The other one, which is even more mind-blowing. So this is World Resource Institute, I think, developed this. So this is 1-meter resolution canopy height model for the world. However, there isn't an easy way to download this, and this is much more cutting edge. There may be problems with the data, but it's coming along fast and pretty amazing. So again, if I zoom in here, to think that this is calculated from space is unbelievable, because we can, I mean, you can see the detail, right? This is individual roads. I know this tree, so we can turn on point inspection. So this is literally one red maple tree, and I'm clicking on it, and it is showing me a canopy height of 12, which is pretty accurate. We look at some of this taller stuff, canopy height of 18, but you can tell there's problems, right? So you see this line here, obviously there's some stuff going on there. But if you want to go in and look at where a road was built or how things have changed over, it's pretty amazing for that. And again, um, the amount of data that takes is just mind blowing. Okay, keep moving here. So the last one that I wanted to talk about was Global Forest Watch. So I think you've probably heard about them reporting on harvest levels around the world and deforestation, etc. This is the tools that they provide the public to access that type of information. So you go to their website, and you can log in here. So it has the normal, what you would expect. Again, that Hansen layer that shows you when things were harvested and when they recovered or turned back into forest. So we go to land cover, tree cover. There's lots of tools that we can look at there. But what is interesting in this case, if I zoom in here, if I go to analysis, I can upload property boundaries for my property. So I'm going to go, so I've created a shape file of my property, saved it as a zip file. I click open on that. So it's going to zoom me in here so I can see it's giving me statistics about forest loss, and so on, which is good. But if I go, let me save areas of interest, da da da. No, I don't want that public. English, save. Sorry, I missed the alert part. I think that was on there. Oh, I'm sorry, I zoomed by that too fast. Anyway, and I think if you saw it there was a tick mark, to allow for, an alert. So essentially I get an email if a disturbance happens on this property. Now, I'm literally only setting this up now. It'll be interesting to see how it works. Maybe if I get an email that I've been out cutting firewood, we'll see. But if that does work, that is pretty powerful. Okay. And again, as I mentioned, if you want to play around in here, there's lots of interesting information that you can bring up, and all of this is derived from satellite imagery in there. Okay, so I'm going to pause there. I hopefully you get the idea. There's satellite imagery, but really the exciting part, is the data that's being derived based on that data and how much of it is actually open source, and free for use. Okay, so I'm going to stop there.